Hi there, and welcome to this lesson on Pure Mathematics 3. And in this lesson, we're looking at how the product rule is used in differentiation. Now, the word product means multiply. In maths, it always means multiply. And the product rule enables us to differentiate two functions that are being multiplied together. So, for example, you could have something like sine x times by e to the x, one function times by another function. Or 2x cubed plus 5x would be a function times by the cosine of x would be a second function. Or 8x cubed times by the square root of 5x minus 3. Now, it is quite easy to confuse this with the chain rule, because in the chain rule, you also have two functions. But with the chain rule, it's where you have a function of a function. So you'd have something like sine of e to the x, or e to the power of sine x. In this instance, we have two functions, but they're totally separate, and they're just being multiplied together. It's normal to call those two functions u and v, where both u and v are functions of x. And then if we're going to work out dy by dx, what we do is we write down the first function and differentiate the second, and then add that to writing down the second function and differentiating the first. Or in function language, if you had f of x is equal to g of x times by a second function h of x, then the same idea. If we differentiate f of x, we'll get f dashed of x, and that will equal the first function times by the differential of the second, plus the second function times by the differential of the first. Okay, let's have a look at an example. Let's say you had to differentiate y equals sine x times by e to the x. So the first function would be sine x, the second function would be e to the x. We need to work out dv by dx and du by dx, and then just put those values into the formula. I'll let you have a go, pause the video, and then come back to me again when you're ready. Okay, let's have a look at these. So as we said, we need to differentiate both of these. So du by dx will just equal cos x, and dv by dx is e to the x. It doesn't change. Then we put all of those four functions into the formula, and that gives us dy by dx is equal to sine x times by e to the x plus e to the x times by the cosine of x. That can be tidied up a little, and we'll have dy by dx equals e to the x into sine x plus cos x. Okay, example 2. A little bit harder, this one, because the two functions that we're multiplying together are more complex. We're going to have to differentiate the function first, and once we've found dy by dx, we're then going to have to use dy by dx to work out the gradient of the curve of this function at the point where x equals pi by 6 and y equals 0. So this time u is equal to the sine of 3x squared, which means the same thing as the sine squared of 3x, but it's just easier to differentiate, and v will equal e to the 4x. To differentiate both of these, we're going to have to use the chain rule. V is a function of a function, the first function is e, and then the second function is 4x. And u is actually a function of a function of a function. So the outside function will be the squared function. Moving in, the middle function will be sine, and then the inside function will be the 3x. I'll let you have a go at doing this yourself first. So pause the video, have a go, and come back to me again when you're ready. Okay, let's have a look. Now, as we said, both of these need the chain rule to differentiate them. So differentiating u with respect to x first. The power of 2 will come down to the front, and then the power will go down to 1. So that gives us 2 times by the sine of 3x. Then we're going to have to differentiate the sine. Differentiating sine gives us the cosine of 3x. And then lastly, we need to differentiate the 3x. Differentiating that gives us 3. And tidying that up gives us 6 sine 3x times by the cosine of 3x. Differentiating v, the outside function is the e, so we need to differentiate that first. When we differentiate the e, we just get e to the 4x. And then the inside function is the 4x. Differentiating that will give us 4. So dv by dx will equal 4 times by e to the 4x. Then we need to substitute all of those into the formula. And when we substitute those in, we get quite a long, complicated looking expression that we can simplify a little bit to that. And then we need to find the gradient of the curve at the point where x equals pi by 6, 30 degrees. So we need to put pi by 6 into here wherever we see x. And it looks like it's going to be quite complicated and a bit of a mess, but surprisingly, it does simplify a great deal. So 4 times x will become 4 pi by 6, 3x will become 3 pi by 6, and 4x, same again there, and 3x, same again here. Now 3 pi by 6, that's pi by 2. Pi by 2 is 90 degrees. The sine of 90 degrees is 1. The cosine of 90 degrees is 0. So all of this simplifies to 4e to the 2 pi over 3, when I simplify the fraction, times by 1, plus 6e to the 2 pi by 3, times by 1, times by 0. Now, because we're timesing by 0 in this second term, the whole term just vanishes. And the first term is just 1 times by 4e to the 2 pi by 3. So this answer does simplify a great deal. And the gradient of the curve at the point pi by 6, 0 will just equal 4e to the power of 2 pi over 3. Okay, example 3. Differentiate y equals 8x cubed times by the square root of 5x minus 3. So the first function is 8x cubed. The second function is 5x minus 3 to the power of a half. I'll let you have a go at this yourself first. Pause the video and then come back to me again when you're ready. Okay, so as we said, the first function u is 8x cubed, and the second function v, it's easier if you write it down as 5x minus 3 to the half. It makes differentiating it easier. Du by dx, we'll do 3 8 to 24, power goes down by 1, so it's just 24x squared. Differentiating v, we will have to use the chain rule. So first of all, it's differentiating the outside function, the power of a half. So we'll get a half times by 5x minus 3 to the power of minus a half when we take away 1. And then differentiating the inside function, the 5x minus 3, that just gives us 5. So 5 times by that. Then we substitute all 4 things into the formula. Substituting those in will give us that. Now, that looks very complicated again. The question has asked us to simplify our answer. So we should try and tidy this up as much as we can. Now, the first thing, just multiplying these terms together and bringing this round to the front would give us that. And it does simplify if we factorize it. Now, factorizing it, what I'll do is I'll take 4x squared times by 5x minus 3 to the minus a half outside the brackets. And then 5x times by the 4x squared, that'll give me the 20x cubed, and I've got the square root term that I want. And here, 6 times by the 4x squared will give me the 24x squared. And 5x minus 3 to the power of 1 times by 5x minus 3 to the power of minus a half, you do 1 minus a half, which is plus a half. So it does factorize into that. Having done that, we can then simplify this final term. 5 6 is a 30, so we've got 30x plus 5x is 35x. 3 times the 6 will give us minus 18. And since we've got this minus here as the power, we might as well put the square root on the bottom of a fraction. And I think that's as much as it can be simplified. So 4x squared times by 35x minus 18 divided by the square root of 5x minus 3. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 133 and have a go at exercise 60. Thank you very much for listening, and cheerio.